All right, so we just took the derivative of arc sine of x. So now we're going to do arc cos of x. And the method of which we derived this is basically the same. We're going to be referring back to the Pythagorean identity, which I already wrote out here for everyone to look at. Basically, I just wrote up here at the top left, y equals arc cos of x, so then x equals cosine of y. This is just the same as what I did last time. Because they're inverses, I can write it like this, because that's what inverses are. All right, so I'm going to use implicit differentiation to take the derivative of both sides of this right here. And that's going to give me d over dx of cosine of y equals d over dx of x. And then, of course, this is going to be negative sine of y times dy over dx. This is just the chain rule. And then this is going to equal just 1 because the derivative of x is 1. Okay, and then I want to isolate dy over dx, so I'm going to divide both sides by negative sine of y. So I'll be left with dy over dx is equal to 1 over the negative sine of y. And of course, I want to write this in terms of x. So what I'm going to do now is refer to this Pythagorean identity, and I'm just going to say, okay, I want to isolate sine squared of y first. So I'm just going to write it, sine squared of y is equal to 1 minus cosine squared of y, right? I just subtracted cosine squared of y from both sides. And then I'm going to take the square root of both sides to just get the sine of y alone. And then that's going to equal the square root of 1 minus cosine squared of y. Okay, and then I can just input this where the sine of y is, and that will end up with dy over dx equals 1 over the negative square root of 1 minus cosine squared of y. But we aren't quite in terms of x yet. So what I'm going to do now is just refer back to our very beginning here, where just like we did last time with sine, and we'll see x equals cosine of y. Over here I have cosine squared of y. So all that is cosine of y times cosine of y. In other words, x times x. So I'd have x squared there. So I could just say dy over dx is equal to 1 over the negative square root of 1 minus x squared. Okay, and that is the plain and simple derivative of arc cos of x. Now, again, I want you to notice where this derivative is defined. I went ahead and got this graph over here from Desmos, and I pasted it in here. This is the graph of arc cos of x. You'll notice it's only defined between these intervals -1 and 1. And if you try and input 1 here for x, where x is 1, you'd get 1 minus 1, which is 0. The square root of 0 is 0. 1 over 0 is undefined. And that's because we essentially have a vertical tangent here on both ends. So if I were to do -1 or +1, you'd see the same result. This x squared would make it just a +1. So it would always end up being 1 over 0 no matter what. And you'll see that we have these vertical tangents, so it's obviously not going to be defined there for those derivatives. Now, that being said, if you were to look at anything beyond -1 or 1, you'd see that this square root becomes negative. It has a negative interior, which is not defined either. You can't take the square root of a negative number, so that is obviously not going to be defined either. For the same reasons, as well as we can't just go back down and continue this loop again, because then it would no longer be a function, and that's the entire point. We're trying to keep it a function. And that's really it. As far as the derivative of arc cos of x goes, you'll see it's very similar to how we took the derivative of arc sine, the same methodology. All you needed was a chain rule, implicit differentiation, some basic trig identities, and that's really it.